Welcome to planet Earth, a tiny speck of life in the vastness of space. This is our home, fragile and special. More than 50 years ago, humans started to venture into space and saw our planet like never before. Space exploration opened our eyes to a new perspective. The International Space Station is the biggest structure ever built in space. It's permanently inhabited, with 6 people currently calling it home. It circles the Earth at 28,000 kilometers per hour, 400 kilometers above your heads. The size of a football field, this orbiting outpost is a shining example of global cooperation uniting Europe, the USA, Russia, Japan, and Canada in space since 1998. Now let's fly a bit closer. On the left, we have the Columbus Laboratory, Europe's major contribution to space science research. Then we come across Harmony, a connecting module where visiting spacecraft can dock. Next to it, there is Kibo, Japan's laboratory in space with a large external platform for experiments. Moving along the backbone of the station, or what we call the truss, is the Canadian robotic arm. This 17-meter robot has been instrumental in the building of the station. It can handle large payloads, move astronauts around, and even capture visiting vehicles. Flying down, we see a few American modules. The largest one is the research lab Destiny. And next to it are the connecting modules Unity and Tranquility. Facing down, it's Leonardo, a multi-purpose module. You can also see a 7-porthole dome called Cupola. From there, astronauts guide operations outside the station and take stunning pictures of our planet. To continue our tour, we'll move to the Russian side of the station. Here we can have a look at a Soyuz spacecraft docked. This vehicle is currently the only means for up to 3 astronauts to reach and leave the station. It serves as a lifeboat in case the crew have to return to Earth. The Soyuz has been used for human spaceflight missions since 1967, longer than any other spacecraft. Time to have a tour inside the station. Let's move to the joint airlock, the main gate for spacewalks. Passing through the hatch, we'll get into a pressurized module called Quest, where astronauts get ready to leave the station or get back to it. The station is a labyrinth. It's not easy to orient yourself in weightlessness. There is no up or down in space. Here we are in Destiny, the American Research Laboratory. It supports a wide range of experiments and scientific studies. We now move through the connecting module Harmony towards Columbus. Let's get in and have a look. Europe's state-of-the-art facility has room for 10 racks, squeezing the maximum amount of research from the available space. Each rack is devoted to different scientific areas. Experiments are performed in biology, human physiology, radiation, material science, and fluid physics. European scientists have remote access to this very special orbiting facility and are producing scientific results for our benefit back on Earth. Just opposite Columbus, we find Kibo, the Japanese laboratory. From here, we can see its hatch at the end, used to transfer experiment facilities to outer space. Next to the airlock, there is a robotic workstation. The crew can prepare the hardware and experiments and put them in the airlock like an ESA astronaut is doing here. After the inner hatch is closed, the robotic arm on the outside can collect the payload and place it onto the external platform. everything floats inside the station. Astronauts and any objects aboard are all orbiting the Earth in a free-fall state. That makes a lot of tasks easier, but it has its downsides as well. Astronauts need to stay fit in space. They have to exercise every day to counteract the adverse effects of microgravity. Bones, heart, lungs, and muscles all lose mass and tone in weightlessness. All these changes are tracked and monitored by storing samples of blood, urine, or saliva in a -80 degrees freezer. In microgravity, they can play with objects like this gyroscope and learn about complex physical laws. A number of activities educate and inspire students all over the world. They can program their own space droids that hover around using their own propulsion and navigation. Or they can learn about how surface tension on water works in space. The crew exercises on a very particular treadmill. They need to be attached to it to not fly away when running. Astronauts must keep a tight training schedule of 2 hours a day.